Hello everyone, welcome back to week 6 stream processing. In this week, we are going to take a look at a very simple Kafka stream example. This example is going to give us the basic building blocks which we will need to maybe work on a bit more complicated case later on. And we are also going to see how keys play an important role when messages are outputted to Kafka. Especially in stream processing, keys becomes a very interesting topic. But we are Welcome back. So I created a class called JSON KeyStream. This class right now doesn't do anything special, so it just has the properties and it does the same properties as in our consumer case. So we just define all the security protocols and all that, which we just copy pasted from Confluent Cloud. So this is needed for Confluent Cloud, and this is just our bootstrap server config. Another interesting method or another thing which we kind of need for Kafka Stream is to create a CERT. CERT is nothing but a serializer and a deserializer. So CERT basically stands for serializer and deserializer, right? So it's nothing really special. What we actually do in this case is we create a hash map. We put what the values are. So we say our JSON value type is of the right class, and then we add it to a serializer, so Kafka JSON serializer, and we also have a Kafka JSON deserializer, and we add the same config. And in the end, we just say, okay, the certs is basically formed by this serializer and this deserializer. So now Kafka would know how to unwrap the message when reading from Kafka. And if it's using the same serializer to put messages to Kafka, it will also know that. So we will use the deserializer and serializer in that case. And what we do is basically we count by p locations. So we have this method key put locations, which we are going to implement now. But we need also certain other properties. So let's add that first. So we have stream config dot application ID config. And this application ID config plays the same role as our consumer group ID used to play in when we are using Kafka consumers. So in this case, let's say Kafka tutorial dot KStream dot count p location. So we wanted to do pickup location dot version 1 for now. And other ones which we will need is basically we will need to say where to read the message from. So auto offset reset config. Let's this time set this to latest. Let's see if we need anything else. Stream config. All right, I think, yeah, we need the cache one. So cache max byte buffering config is basically 0. The reason we are doing this is so that we see our messages immediately. Otherwise, Kafka caches some messages before producing it, because sometimes the same key is updated multiple times, and instead of buffering the cache or buffering it in memory and then producing it, we just want to produce each and every message single time so that we have a quick feedback loop. All right, and I think that's it. So the first thing we need would be a stream builder. So we will have a stream builder. And then the stream builder will stream from a particular topic. So our topic in this case is writes. And it takes another one, which is basically called consumed. So we will say consumed dot with. So our key serialization is our string certs. So string serializer certs dot string cert, and our value deserializer is basically coming from our get JSON cert deserializer here. I think we will name this through here. I think it should work with maybe the certs dot string. Yeah, this one. Okay. So I think this one does the same thing we did. Yeah, it actually does the new string cert, but this is a shortcut. All right, now we have our stream. Let's see what the stream returns. So stream returns a Kafka stream, and let's do that. So we have now a Kafka stream. What message does it provide? So it provides plenty of messages like filtering, flat map. There should also be, so you can join. I think there's also map. You can also just map values and all that. But for us, what we need right now is just group by key. So why do we need group by key? Because we are producing our messages with uh, with the with a pickup location ID, and all we need in this case is just group by pickup location ID. And the second thing we need is just to do the count. So let's see what this produces. This gives us a K table. Uh, so we would like to stream it. So we will just say to stream. This will give us a K stream. So I will say count or K count stream. So now we have a K count stream, and we can just output it to a particular topic. In this case, let's create a topic called rides count, or let's say rides PU location count. Let's see what the parameters are, and we can see that we have a producer. If we do not specify this, this will use the same one as we use for reading, but that's not the case in this one. In this case, we would need to output string and JSON. Sorry, string and long, but what we are reading is basically is string and JSON. So we would need a producer or produced dot with search dot string. So that's the shortcut, and in this case we would need search dot long. Perfect. So I think that's it. Now is basically go to Conflict Cloud and create this topic which we are interested in. So let's create a new topic. The topic is P locations. We do not want to define any data connect right now. And obviously right now there are no messages coming in. So the next step, what we would need to do is basically, now we have our stream processing. So the topology is ready, but we need to do something with this topology. So there's a class called KStreams. So we will create that. KStreams, a new Kafka streams. And this will basically be our stream builder dot build. I will take the properties. Basically, this K stream has to be started. So another thing which we can do is basically add a shutdown hook, and that will be thread K stream dot close. So now there's a shutdown hook in which it will close the K streams. Let's just rename few variables here. So this is our rides stream, and this is our PU location. We say PU location count. Yeah, and basically that's it. So now we have created a successful Kafka Stream application, and let's start this one this time. So now we can see that it's waiting for the messages to come in, and basically it just keeps it running. So another thing what I did was, instead of producing all the messages in one go, I just added a thread.sleep 500 to our JSON producer, and I changed the pickup date time and the drop off date time just to be now basically. And we just say, okay, this is the ride was for 20 minutes. Not super smart, but I hope this works. So let's take a look. So the Kafka stream is running. Let's maybe go to our topics, go to rides. And in rides, we can maybe see, yeah, we already see that some messages are coming in. This is because our producer is running. Let's go to write speed location count. And yeah, and we already are seeing that messages are coming in. So if we go for the key 75, this means this is our PU location ID. The value which is coming is basically 1 in this case. And that basically means that this is 1, there is then date of 2, 1, 2, and these are the long values which we are taking a look into. So let's see what doesn't provide anything right now. Let's refresh. Maybe something else shows up. Yeah, and now it's already going till 8, 5, 4. We can see that these messages are now flowing in. And yeah, and this is our basic example of using Kafka streams, and we are counting using that. So we did take a look into how a basic Kafka stream application was built, but let's draw the same Kafka stream application we had already, right? So what we got in this case was basically some rides coming in from our topic, and we grouped it by key. Grouped by key. This key was our PU location. And then once this was grouped, we basically counted it and outputted it to a new topic, which was our PU location count topic. Correct? This was basically our flow. But there was something very interesting which happened, which was basically the keys. So now in our case, we only had one application running. So there was just one app which was running. So the rides topic had two partitions, and we already discussed this in the last video that both these topics would be assigned to this one app, and then everything works as normally because the keys are not distributed across different apps. So now let's take the example of what happens if we have actually two apps which are running. So we have the first app, which is basically the stream processing, and the second app, which is also our stream processing. And in this case, what will happen is partition 0 will get assigned to one app, and partition 1 will get assigned to the second app, and everything else flows the same. So the group by will take place in both the cases, and the count will also take place in both the cases. But the count might be wrong if the data is not distributed correctly into the rides, right? Like into different partitions. We are grouping by key. The key plays a kind of a role in how do we partition our data, right? Like because otherwise this count would just be wrong. If let's say key K1 goes to app 1, and then we output K1 is equal to count 1, and then the next K1 key goes to partition 2, which goes to our second app, then we will again output K1 is equal to 1, which is not correct. This should be actually 2 in our case. So how does Kafka basically solves this problem for us? So what Kafka does is when we are producing our messages, so when the producer is writing to Kafka, and that's basically our writes topic. So let's maybe use this kind of a symbol for the topic. What happens in that case is basically the producer is writing to different partitions, right? So it's writing to partition 0 and it's writing to partition 1. You can also control this and basically say, okay, I want to write this message in a particular partition, but then you need to make sure on the consumer side that these things are known. You can also choose your own partitioning strategy. But what happens in Kafka, so what happens in the library which we are using is basically it says, okay, I will hash the key. So hash the key which is sent in our message, and we modulus it by the partition count. So in this case would be basically 2. And what we will get is basically 0 or 1, and that can divide, and that's basically how different messages or different events get divided into different partitions. So the main part is that what the main thing what happens is basically the key plays a really important role here, and the key is used to determine which partition the data will go into. If we say, let's now take an example. Let's say so we have K1, K2, K3, and then K1 again. So what will happen is we will basically hash K1 and modulus it by 2. And let's say the answer was 0. So this will be basically going to partition 0. Then we do a hash of K2, modulus 2 again. Let's say this was 1. So the data will go into partition 1. Then we hash K3 when we see the K3 message. This will basically go, let's say, into 0. So we go into partition 0. And the K1 again. So now the hash will produce the same results. So the results in this case and this case will be absolutely the same, and this will be 0. And there, now this is where the consistency comes from. This is where Kafka can guarantee that if you are producing a message with a key, it will directly go to that particular partition. And later on in your stream processing or in your consumer, if you are reading a particular partition instead of like the whole topic, you are guaranteed that you will always get the keys in the same app or the same application which is running, right? So your second pod, let's say, for that case. There's also an interesting case. What happens when key is null? Because that is an option. When key is null, it goes in round robin fashion. And basically it will produce one message to partition 0, one message to partition 1, then one message to partition 0, one message to partition 1. This has a big advantage. Basically, data is always equal in different partition, or data sizes. Actually, it's a better way of defining it. So the data size is always equal in different partition. That might not be the case in our hashing solution, because you might have a lot of events coming with K key 1, or maybe a very famous pickup location, which might be an airport. And in that case, your data is a bit skewed. And the data skewness actually forces one partition to have way much more data than the other partition has. So even if you scale your application horizontally, there might be an issue that partition 0 is always lagging just because it has so much data to process, because the famous pickup locations are just going to partition 0 or hashing to partition 0. Obviously, a solution for this is the same solution we use to fix data skew, is to basically recognize these patterns or these very famous pickup location, and then add some sort of randomness to that. So basically, we might divide all these keys into 2 parts and say, okay, the airport location is divided into 2 different parts, and we make sure that they go to different partitions. So we can use all these techniques, and obviously on the consumption side, you need to be aware about what kind of like assumptions you made when you were partitioning your data. Generally, our data is quite nicely divided into different partitions. At least practically, I have seen that. There might be some cases, but generally you are aware of that cases when it already, like before you start building your application. And if you are not, then you definitely see this pattern happening in your consumption side, and then you can quickly rectify it. But that's it for this video. Thank you so much. I hope you understood something. And in the next video, we are going to basically take a look into joins, and we are going to basically join to Kafka Stream and see how to build that up. See you next time.